The NC Lab 2020 webinar series is funded through a grant from the Institute for Museum and Library Services and provided to the Nevada State Library Archives and Public Records System. The topic for webinar 4 is Introduction to Computer Programming, Karel, Unit 3. Welcome back, everybody. In this webinar, we're going to go through Karel Programming Unit 3. And this is where we're starting to build more complex programs. In Units 1 and 2, you learn an awful lot of basic principles, and you know how to write code that will work, that will meet objectives, and you can do it within limitations. You can look for repeated patterns and control them with repeat loops and while loops. And you can write programs that handle unknown conditions with if-else statements and while loops. You understand that Karel is sensing objects, and you know how to use the Boolean operators and, or, and not to modify your conditions. You've also picked up a few algorithms that you can reuse. In other words, once you've figured out an algorithm that makes sense, it's like having a little library that you just call on. They say, oh yeah, if I need to turn Karel around, I can just make 2 left turns to do that, or 2 right turns. So I've solved that problem once. I can now use that solution again and again. So our programs are going to start getting more complex and longer, and now we need to learn how to organize the code so that it's manageable, that it's easy to read and edit, and it's efficient. So this is what we're going to use, and this is what we're going to learn in Unit 3. How to write programs that solve more complex programs by breaking them into smaller problems. And that's the key there. If you can break it down and solve each piece logically and put them back together again, then you can solve some pretty complex problems. And one of the ways we do this is by organizing our code into keywords. A keyword is a word that you write in the program, and it calls a set of commands and executes them. And you can use that keyword over and over again in a program. We're also going to learn how to comment code so that it's easier to understand and manage. Even though Karel is quite readable, you might still have several lines of code that you don't want to spend all day trying to figure out what they mean. If you write a comment ahead of that section of code that says this is what this code's going to do, that's very helpful. And comments, they're very simple. You just start them with the pound symbol or the hashtag symbol, and you can just write anything you want, and you can insert them anywhere. Just so you know, they don't count against your points for lines. Comments are invisible to the actual running of the program. It's just more for the human end so that we know what's going on. We're going to assess our programs for efficiency with a variety of factors. So we've been working really hard on writing shorter programs, but these don't necessarily work more efficiently than a longer one. And there's some nice examples in Karel that show how that happens. And we're going to use some more complex algorithms. So there's a couple of algorithms that we use to navigate the mazes. You were introduced to the first maze algorithm in section 10, and you're going to pick up the second maze algorithm in section 13. Then we're going to dive into variables. So you can, instead of using a number, a fixed number, you can assign it to a variable and then just call that variable when you're running a function. And you can also update variables. So we're going to work with counting variables, and these are used to collect, tally, and report data, such as the number of objects found or the length of a wall. That helps us make decisions based on the data, even within the program, and we can print out the results. So that's one other thing we're going to learn, is how to write print statements. And then we're going to take this all this learning with keywords and counting variables and start writing functions that return values. So this is getting a little bit more numeric. And also understand how local variables are used within a function, and global variables typically are used in the main program. That's a little bit overgeneralized, but this is an important concept in programming. So again, Karel seems like a little game, but you're learning some stuff that will help you with any programming language and programming task. Just to comment again on the section numbering and level numbering. We're working through sections 11 through 15. And the way we define a keyword in section 11 is to use a def statement. It will have the same structure as our repeat and while loops. The commands are indented, so anything that's indented after the def statement these are the commands that will get carried out when we call that keyword. So let's see what that looks like in Karel. So we start with section 11. We start by demonstrating why you need these defined keywords. Here's our story. All right, so you can see there are clusters of computer chips here, and Karel's going to go and collect these and eventually get to the home square. If we write out these commands sequentially, we end up with a very long program. You can see it's 83 lines long. I'm going to run it in turbo speed so you can just see how it works. And it works, but it's not very efficient. As you can see, it's just going line after line. There's still lots of repeat loops, which helps organize the code somehow. But that's an awful lot of lines of programming and a lot of things that can go wrong when you write that much programming that could be better organized. So what was the common factor here? It was what Karel, sorry, let me redo that. Karel is collecting the same cluster of stars, just in a same cluster of chips, just in different locations. So in level 11.2, now we're going to take that procedure that's used to collect that group of chips and put it in a keyword star. So all that stuff that was being done is going to be done when we call the word star. And we'll just take a look at this program again. So now we have the keyword defined at the beginning. You always put your definitions ahead of the program. And there it is. That's that procedure. And then in the main program, all we're doing is we're getting to the starting position, and then we're running that keyword. And then we're moving to the next starting position of the next star, and then running the keyword. And the same thing again, moving to the third star, running star. Moving to the fourth star, running star. Moving to the fifth star, running star. And then finally some code at the end to go home. All right, let's look at how I'll start slow because I want you to see how it reads the keyword and then jumps to the main program. So I'm going to set it on medium, and then we'll speed it up. So there it went and read the function, and now it's going to the main program, and now it calls the function. That should be keyword, not function. Functions are written the same way. It's done, goes to the next star. And now we'll let Karel finish his job. And it goes back and forth. It runs the function, the keyword up here anytime it needs it. So that's how keywords work. And then in section 12, you're going to get a lot of practice writing keywords, and you'll also pick up the second maze algorithm. And I'm not going to run this through, but you can see this is a very irregular looking wall. And this algorithm will work on any wall that is of this type of configuration. And Karel uses its sensors to sense the presence of a wall and responds accordingly. So that's basically it in section 12. In section 13, we're going through a number of examples, and you can see these mazes look messy and complicated. But again, it's giving you practice on organizing the code, but also it makes a point that code might be short but not efficient, and you could write it a different way that's where the code is slightly more lines, but it solves the problems more efficiently. I'm not going to go into that right now. The examples are at the beginning of the section, but you can see here just a little bit of from the examples we looked at in 11. You can see, oh well, that's a pattern there, and that's a pattern there, and that's a pattern. The way Karel navigates this maze, it's the same size block. I could use a wall following algorithm and an if statement for collecting coins, and I could apply it to each one of these even though they have different configurations. In this one here, it looks like Karel's going along a row and there's an opening at some point, and then Karel's got to get into that next row. And so I can see the tasks that can be organized under keywords. All right, let's go to section 14. Section 14, this is where I think you're getting into some real computing power. This is where we start to work with variables. So we're naming a variable and then assigning it information. And in this case, we're using what are called counting variables. And so we initiate it by just giving it a value to begin with. If we're counting up, it would start out as a 0. And then every time Karel finds something, you can add to that. And now we're learning some computer commands, like the word ink will increase the value of a variable by 1. So Karel's now collecting data. And then the other thing is we're starting to output what we find as a print statement. And print statements can be put anywhere in a program. In fact, you can use them to monitor how the program's doing. Every time it does something, you can get it to print out that information. So, and let's just look at the quick demo here, story. Okay, so here's the demo, and anytime that you're testing something that can change, you have more than one maze. So this has got 4 mazes it might select from, and all that Karel is doing is walking in a line, and if there's a map, Karel picks it up and it counts what it's picking up. So let's see how that looks. All right, so there's our variable n, and it's assigned a value of 0. And that's the print statement. So it's saying, yeah, it's a 0 right now. Okay, we have 8 squares, that's a fixed amount. And so Karel's going to look for a map, and if the map is not there, he follows the else branch, there's nothing there, and he prints out the statement that there's no map here. So you're not only getting a count of the maps, this information could be stored in a list, and you could find out exactly where those maps are. I'm not doing that in this level, but this is, we're getting into a little bit more real world type programming skills here. There's a map found, and then the value's been increased. And let's scroll down so you can see that. So these are all the print statements being generated down here. And no map, found a map, increase the value of n, going to print the value of n is, goes one step forward, and there's the new value of n, and so forth until we finish the repeat loop and end up on the home square, and we're done. So this is now a document. You've got a document of all the information here. It's starting to look like real programming. So Unit 14 is all about working with counting variables. This Unit 15, I think I went through it about 3 times before I got it all. And even now when I go back, I've learned something new. It's pretty deep. And so this is where, you know, patience is a virtue. But now we're not just writing keywords anymore, but we are writing functions, and the functions will return a value. So just like, you know, while there, you know, here's that defined counting variable, and every time he goes along, he's incrementing that value of s, and then that value of s is now returned to the main program. So this defined keyword, it's also a function, it's going to return a value that we can use. And then the value that comes back from the function can be assigned to a variable in the main program, and then you can print out the number of steps that he took. Or you can even print it out as the function return. So like I said, this is really getting into what 99% of what people write in programs are functions that return information. And here's the example. There's Karel. He's got a length of wall here. So we'll just run through this. And you know, the nice thing at the beginning of each of these sections, there's a demo unit, or demo level, I should say. And it'll, if you step through them, of course, they force you to use the step button because there's no run button. But you can really see what each part of the program is doing and when it gets called. So we're in the main program, and eventually what we want to find is the length of this piece of wire. And wire, every time Karel goes through wire, that number is going to get increased. And something I'm not sure if I pointed out before, but the algorithm for every line is written at the bottom of the screen. In this case, length equals wire. It says, I will call the command or function wire. That's what it's going to do. Okay, so now we have a 0 to start with. And as long as there's a wall, Karel's going to increase that value and print out. And that's a monitoring print statement. So we know so far this is working correctly. And there's a 3rd section, and a 4th section, and a 5th section. Okay, and then he's going to go, and no more wall. So that's going to get out of that while loop. There he goes. He's going to go, and now he's going to print the results. Function is returning 5. He's just going to jump. There's your return statement. He's going to jump out of the function and back into the main program. And then he's going to print out the length of the wire based on what that function returned. And there it is. Dun, 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 loading data. And that was the results. Length of the wire is 5. So a lot of times when you're running any kind of app, all this stuff is going on inside, and it comes out, it spits out a number, and it presents you with a nice bit of information. You know, the temperature right now is 77 degrees. So that's, you're getting into how programs work. It does go into a discussion of what are called local and global variables. Again, I think sometimes it takes a few times running through these levels to get it, and certainly stepping through a program shows you how it works. So just like the other units, you get a certificate, and now this is starting to look like some pretty serious stuff that you've learned from Unit 3. So you know, the videos and documents are loaded into the revised schedule as soon as they're ready. So you can revisit that and find them at any time. So the links are all there. Now in the recordings, because our discussions are very much within the library system, I'm not making these public links. So you have to click on, you have to have the link in order to see it. You'll see that I do blur out your faces, so I do protect your privacy in any kind of side conversations. I've taken them out as well. But that's how you get the links. They're not going to be on, they're not public. They are by link only. And then any materials, these links will open up those materials. So there's that PDF guide from the first webinar. Anything you want to ask on this or anything else that we've covered so far?
I just need to start from the beginning, maybe, to get it.
Yes, yeah. It's, well, you know, I've been living with Karel's for 6 years. I think the first time I did it was in 2014. And every time I go back, I learn something new. I always think of Karel as it's like playing chess. You know, the board is very simple and the moves are very simple, and you can learn them when you're 6 years old, and you'll still be learning how to operate it when you're 90, you know. And that's the beauty of a learning method like Karel. It's very visual. It gives you immediate feedback. That you see your command, and there's Karel turning left, and what happened? There was a wall there, and how did he react? And so you're processing all this information and getting all this feedback, but you're not dealing with some real world problem that's, you can't even figure out how to split that problem up and find the right code to solve it. It's just a wonderful learning tool. So yes, and again, you know, if you're a librarian and we have you set up as an admin or a teacher, you get the solutions. So you can cheat a little bit that way. And if you're not already set up that way, just email me. I'll make sure you are.
Okay.
Yeah.
Thank you.
All right. Any other questions? Okie dokie. Norma got the postcards, so apparently she's sending you out some packets. So you'll get some of those in there to do with as you see fit. And so I wish you all a great weekend as well. And thank you for putting up with this gnarly technology.
Thank you.
Sure.
Thank you. Take care.
Thank you. Have a nice day. Thank you so much.
Bye-bye.
Bye-bye.